And here we go. We will start right now in order to discuss about the second session of the day. So this is day two of our weekends only CCNA training. And yesterday we did discuss about the very fundamentals of networking and how it actually works with IP addressing and prefixes and subnet masks and so. You can drop a query if you are looking forward for if you're having any issue accessing the videos or so. You can reach out in our Telegram group. Okay, so you can either contact on Nitish or Dipanshu for the same, and they'll assist you with the same. Okay, yeah, thank you. All right, I'll share my screen then. And there you go. I hope you all can see my screen now. Please confirm the same. Great. So yesterday we did discuss about class C subnetting, right? In which we discussed about different subnets, be it /25, /26, /27, and so on. However, I'll just review the same. And today we are going to discuss about class B subnetting and class A subnetting. So in order to review the same, if we talk about a subnet mask, let's say 192.168.1.0/28, let's say. So to figure out the number of mm, networks, number of hosts, subnet mask, and ranges, the formula that we have been using in the previous class was something like number of network, then number of host, and then subnet mask and ranges. That's exactly how what the four things that you actually figure out. Okay, when you do any type of subnetting. So the first thing first that we do while we figure out subnetting is convert. Oh, my voice should not be low. Am I audible? Guys, please confirm if you can hear me pretty good. Yeah, there is no issue with the voice from my side at least. Perfect. So first thing first is when you like have a subnetting to be done, then what you need to do is you need to convert this CIDR into the binary bits first. And when you convert it to the binary bits, then you actually do write it down in a way. The first 8 bits, the second 8 bits, the third 8 bits. And then as we are talking about 28, so it means that you have borrowed 4 bits from the host portion, and then rest of the 4 bits are going to be same for you. Makes sense? So you can say this is network, 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 again network, and the host. This is how the network is actually divided. And that kind of brings you that the number of network that you're going to have is 2 to the power 4, which will be 16. And then the number of hosts will be 2 to the power 4 again, which is again 16. And the subnet mask can be figured out with our master formula, which can be 128, 16, sorry, 128, 64, 32, 16, 8, 4, 2, and 1. So as we have turned on the 4 bits, we just put the first 4 bits, add them together, and that's how you would write down the subnet mask to something like this: 255, 255, 255 dot 240. Because if we add 128, 64, 32, and 16, it becomes 240. And the range, of course, will start from 192.168.1.0, and it ends up at 192.168.1.15. That's how it's gonna end. The second network then, however, will start at 192.168.1.16, and it will end up at 192.168.1.31. And then the next one will start at 32 and end up at 49 and 50 to 63. Okay, like okay, this is going to end up at 47, and it will start at 48, not 50. So yeah, that's how the thing are going to go. And then the last subnet will be 192.168.1.241, and it will end up at 192.168.1.255. And totally, these will be 16 networks, each having 16 IP addresses per network. And the starting IP address of every network is going to be network ID, and the ending IP address of every network is going to be the broadcast ID. Make sense? Do you understand that? So this is how we actually do class C subnetting. However, the number of bits that you can have in class C can go till slash 32, because you see, the last 8 bits or the last 8 values are dedicated for the host portion, which actually starts at 25th bit, then you have 26th bit going towards 31st, or sorry, 32nd bit, right? Like that. So when you actually see that 32nd bit can also be done, but you cannot really have subnetting that can be done for slash 31 or slash 32. And why we can't do subnetting for slash 31? Because when we figure out that slash 31 can actually be subnetted, but then the output of that comes, that number of network would be 2 to the power 7, which will be 128 network. Number of hosts will be 2 to the power 1, which is going to be 2. So as you will only have 2 IP addresses per network, these 2 IP addresses will be counted in a way that the first IP address will be network and the last IP address is going to be broadcast. Make sense? So there won't be any IP address that will be left that can actually be used to be assigned to any of the interface or so. You get that? So that's why we do not really use slash 31. And same is going to happen with slash 32 as well. That you won't be able to consider or have any of the IP address that can actually be assigned to someone. Makes sense? This is how the thing actually works over here. I hope you understand that. So after figuring out that how slash C subnetting actually works, what we are going to do is we are going to consider doing slash B subnetting. And class B subnetting spans from slash 16 to slash 23, which means if we look at the default subnet mask, then class B has a range of IP address starting from, or the first octet can be from 128 to 191, right? And then the network prefix and host prefix calculation for class B is equal. So you have 2 network prefixes and 2 host prefix, and the default subnet mask is 255.255.0.0. You get that? This is how the scenario is over there. And let's say that you want to figure out a subnet mask, or if you want to figure out subnetting for a network that starts at 172.16.0.0/23. And for this subnet, you figure out number of network, you figure out number of host, you figure out subnet mask, and you figure out ranges. You get that? So number of network can be calculated, or number of network can be thought of in a way that 2 to the power 7, 2 to the power, uh, now 2 to the power 7, if we think of that, number of network can be 128. And how much would be number of hosts? 2 to the power 9. Because if you think of it, if you think of the CIDR in a way of binary, then by default you will have 16 bits as on 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. Then when you consider the same thing over here, you can say that by default, these all will be the host prefixes. Correct? So these are the network prefix, or you can say, and these are going to be the host prefix. This is the default scenario. And in this case, you will consider that the CIDR for this is /16. But as you are having the CIDR for, you can say, /23, then what is going to happen over here? The binary bits will be converted in a way that first 7 bits will be borrowed from the host prefix and they will be converted into network prefix. You get that? So that's why we are going to, I would say, erase the first 7 bits, and then we are going to convert those 7 bits into, right? And then we will write it in a way that this is again going to be the network part, and then you will have a host part like this. And now you can see that totally there are 23 ones, and then there are 9 zeros. We consider 7 as borrowed because we are working with /23, and by default /23 is part of class B. So that's why we say that /16 is the default one. And then after that, as we are moving for /23, so we will consider that 23 minus 16 is 7. So 7 will be acting as borrowed bits. Make sense to you? And then the remaining number of hosts are going to be 2 to the power 9. And that 2 to the power 9 value for that will actually result into something called 512, which means that you're going to end up having 128 such networks, and in every network you're going to have 512 IP addresses there. You get that? Then we will write down the subnet mask, and the subnet mask for /23 is going to be written in a way 255.255 dot. And then after that, you will use the same master formula 128, 64, 32, 16, 8, 4, 2, and 1. And what you're going to do for the third octet, you're going to add these 7 bits according to the master formula, and then you're going to put it over here. And how what those value will be? That particular value will be 254.0, because the last octet is all 0, right? That's why the value will be like that over there. And then the ranges start. So this is the most crucial part of our understanding the class B subnetting. Okay. In that, where do we start? We start with 172.16.0.0, and we end up at 172.16.0.511. Do you see? Can we write that particular network like this? Is it correct? No, we cannot write that like that, right? And for the same, how would you write it down? You will write it down in a way that if your network starts at 192.168.0.0 or 172.16.0.0, then it will of course end at 172.16.0.255. It cannot cross the boundary of 255 or cannot go to 256 or so. So how do you make it work then? Then you go and change the third octet. You get that? If you have heard if you saw seen the speedometer of a car or something, you have different like numbers there or digits there. Let's say these are the five digits that you have, and when the last digit actually goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, then it again starts from 1. But for that change to take an effect, this particular last second bit will also change to 1, and then the value will start from 11, 12, 13, 14. Once it reaches to 9 again, then again the second iteration will start, but the second octet will change to 2. You get that? That's how you reach out to 100. So when you see this, then once your last octet reaches out to its limit, that is 0 to 255, then you can say that you start with the third octet then. So you will write the next network like this: 172.16.1.0 to 172.16.1.255. And when you combine both of these networks together, if you merge both of these networks together, how many IP addresses are you going to have? For the first network, you're going to have 256 IP, and for the second network, you're going to also have 256. So when you merge them together, totally you have 512 IP. So if I write it down in a way that the network actually starts at 172.16.0.0 and it ends up at 172.16.0.511, then this is a network that contains 512 IP address, out of which 0.0 will be the network ID, and sorry, no, not like this. This will be written as 1.255. Yeah. So we are starting over here and we are ending over here directly. So over here you can say that 0.0 is the network ID and 1.255 is the broadcast ID. And when you specify that, you can say that the network here contains 512 IP addresses there. Make sense? Just like that, the next network now will have something in a way that as we are going to start with this, then let's write it in a good manner. And the first network now is going to be from 0.0 to 1.255. Then the next network will be 172.16.2.0, and it will end up at 172.16.3.255, and then 4.0 to 5.255. So if you know that we are actually merging here two network octets per network there, okay, one segment is equal to 256. So what we are doing, we are merging multiple segments over here. And then by merging multiple segments, you are actually forming up one of the network that is required there. So like this, you are gonna have 128 network. And when you reach out to the last, your last network will look like 172.16.254.0 to 172.16.254 sorry 255.255. That's how the network will be, and totally you will have 128 networks, each network having 512 hosts per network. Do you understand this? Great. Now here's the thing. How do you figure out that how many number of segments do you need to merge? Like over here, if you consider that 0 and 1, 2 and 3, 4 and 5. So you can say that you are merging around two segments of 256 IPs for each network here. Now last network will not be 255.0, it will be 255 to 55 itself. So how do you figure out that how many number of segments should be merged here in order to figure out the value? So you just consider a logical operation here that whenever the number of hosts is gives you a result that is greater than 256, then divide that particular value by 256. If your number of hosts is coming up with a result that is 256, that is greater than 256, then divide by 256 itself, and then the answer to that will be 2. Makes sense? And this is how you actually figure out that what should be the number of segments that you need to merge together. So over here we have merged two segments, 0, 1, 2 and 3, 4 and 5, 6 and 7, like that. You get that? Let me give you another example there. If you work up with something, for example, 172.16.0.0/22, let's say. For this, we will figure out number of network, number of host, then we'll figure out subnet mask and ranges. So the number of network over here can be 2 to the power 6, right? Which is going to be 64. The number of host can be 2 to the power 10, which can be 1024. And then a subnet mask will be 255.255.200, 252.0. And then if you need to figure out now what should be the ranges, because the range of course will start at 0.0, but would it end at 1024? So you need to divide this value by 256, and the number of segments that needs to be merged will come out as 4. So when you start at 0, you actually end up at 3, because you need to merge 0, 1, 2 and 3, because 0.0 will end up at 0.255. Then you will start with 1.0 to 1.255, then 2.0 to 2.255, and 3.0 to 3.255. And entirely each of that particular network has 256 in each network, multiplied by 4, that gives you 1024 hosts, like this. So you start up at 0.0 and you end up at 3.255. Like that, you merge 4 segments. Just like that, when I said that your network is going to start then at 172.16.0.0 and you will end up at 172.16, I would say 172.16 3.255, and then you will start at 172.16 4.0 and end up at 172.16 7.255, and like that the last network will be like 172.16 0.0, sorry, not 0.0, 252.0, and you will end up at 172.16 255.255, and totally you will have 64 networks where you will have 1024 hosts per network. Do you understand this? Perfect. So go ahead, try this thing as slash, try this thing for slash 21, slash 20, and slash 18 and see if it works for you. Okay, consider the same network and see if it works. I'll be back in around, I'll give you around 20 minutes of time. Thank you. Hi guys. Most of you have been talking about no audio, no audio, no audio. It was an assignment time that I asked you to solve the thing that I gave you, but that's fine. Anyways, so I'll solve the assignment questions for you as well. Where let's see. Yeah, I'm gonna explain that. Don't worry. So let's try /21 again. When we tried for /21, you can see. Let's say 172.16.0.0/21 is what we are trying. And the first thing first, what we will be doing, we will try to convert this into binary. So the 16 bits for class B is going to be same, right? So we say 1181 ones, next 8 ones, and then as we are solving it for /21, we will have extra 5 ones that will be acting as borrowed ones. So we'll say 1, 2, 3, 4, 5, and then we say 0, 0, 0, or that 0, 0, 0 actually is going to be host portion. And then we say rest of 8 bits is going to be host itself. Make sense? Now, if we figure out the number of networks, then the number of hosts, then subnet mask, and ranges for the same. Then the number of networks will be 2 to the power 5 because we have 5 borrowed bits, right? And that will be 2 to the power 32. Oh, sorry. The answer will be 32 there. 2 to the power 5 is 32. And then the host will be 3 this bits and 8 from the last octet. So we say 2 to the power 11 there. That will actually be 2048. And then the subnet mask for that will be 255.255 dot 248.0, because we need to add the first 5 digits from the master formula that we have. So when we have 128, 64, 32, 16, 8, 4, 2, and 1, as we have borrowed first 5 bits here, we will be adding up first 5 bits. And the addition of that is 248. So that's exactly what we will write down in the third octet. And then when we figure out ranges, we need to first make sure that what's going to be the number of segments there. So we say divide it by 256, and that actually becomes, when you divide it by 256, then the value becomes 8 there. You get that? So this is going to be the number of segment. Now the range will actually start from 172.16.0.0, and it will end up at 172.16.7.255, and then 172.16.8.0 to 172.16.15.255. That's going to be next segment. Then 172.16.16.0 and 172.16.23.255. And till we will go to the last network, that's going to be 172.16.249.0 to 172.16.255.255. Like this, these will be 32 networks, and each network will have each network will have 2048 hosts per network. Do you understand this? We divide it by 256 to get the able to figure out that how many number of segments do we actually need to merge into one of the network. You see, we are actually over here, we are starting from 0 and we are ending at 7. It means that 0, 1, 2, 3, 4, 5, 6, and 7. These are the 8, I would say, segments. And each segment contains 256 IPs. So when we multiply it by 8, then we get the result as 2048. So when we segment or when we merge 8 such segments of 256 IPs, then we get one network of 2048. Do you understand that, Rahul, now? Yeah, go ahead, Arijit, ask that. The range limit is calculated in a way that the number of segment decides how many segments do you need to merge. So you go from 0 to 7, that is 8 bits, then next 8 to next 8, then 16 to 23. I'm just adding 8 segments per network. And the IP for the last octet will start from 0 and it will end up at 255 every time. Okay. And what I'm doing over here for the last one, so if you figure out that the last network is of course going to end up at 255 every time. Yeah, that's correct, Amar. Now when I'm figuring out that 8 is the number of segment that I can have at max in order to have 2048 as number of IP address per network, then I figure out the last network, that is 255.255. And what do? I just subtract 8 from that. So I know that we start at 249.0 and then we end up at 255.255. The second last network for the same will be in a way that you start at 172.16.240. Okay, this will of course, yeah, this will be 248.0. So we start at 240.0 and we end up at 172.16.247.255. That's how you add 8 different networks there. Makes sense. This is pretty easy. You'll need to practice this, and when you practice it a lot, then you'll figure out by yourself that what I'm talking about here. Next, let's talk about slash 20 here. That if I come down with the same example for slash 20, then what will happen in slash 20 is I'll change this thing to, and then what will happen? The number of hosts or the number of borrowed bits will change to only 4 now. Now, how would you figure out the thing? Number of networks will be 2 to the power 4 there, which is going to be 16 network, and number of hosts will be 2 to the power 12 now, which is going to be 4096. And then subnet mask will be 255.255.240.0. And then when you come out to figure out the range, now it's of course gonna start from 172.16.00, right? Can I go and say 172.16.0.4095? I cannot do that, right? So for the same thing, what I'm gonna do, I'm gonna figure out that how many blocks of 256 can I merge to get one big network that can consist 4,000 IP addresses. And that's exactly why I, okay, just a minute. That's exactly why actually I divide these segments. So I say divide it by 256, and then I say the number will be for me, that is going to be 16. So then I get to figure out that if I start at 0.0 in a way that 172.16.0.0, then I can end up at 172.16. You just need to go till 15. So 0 2, I cannot go to 16. This will total be 17. So I say 0.15 there, dot 255. And then the second network will start at 172.16. Uh, 16.0, and we say 172.16.31.255, and then I say 32.0 to 47.255, and 48.0 to 63.255. Like that, I will have the last network as 240.0 to 255.255, like 172.16.255.255. Do you understand that? Excuse me. Yeah. Do you get that, guys? It is actually similar to class C itself, but the only thing that is different is the modifications are happening in class in third octet instead of the last octet. That's the only thing that you have. Make sense? I'll request you to practice for everything that is possible there. Like when you talk about class C, then I would request you to please practice for slash 25 to slash 30. When we talk about class B, do practice it for slash 17 to slash 23. And more you practice, the better you will understand how this is actually working. It is pretty the only thing that you need to practice there. And once, like, the more we practice, the more you get there. Cool. After discussing this, what we are going to do, yeah, the actual number of hosts will be then less than 2. So when you have 4096 as the number of hosts, the usable number of hosts is of course going to be 4094 there, like an odometer. Exactly. Yeah. So now we are going to discuss about how class A subnetting can be done. More complex now. So when we talk about class A subnetting, then we will practice. Now class A subnetting spans from slash 8 to slash 15. Okay, and we will try slash 15 first. So I'll take an IP from class A, that is 10, and I'll say 10.0.0.0 slash 15 is what we are trying, where we only have the network prefix as the first one and every other thing is host prefix. You get that? So when I try to, I would say, write down the binary of this slash 15, it looks like this. The first 8-bit will be constant. These 8 bits are going to be constant. Then the next 7 bits is something that we are actually borrowing. And that is 1, 2, 3, 4, 5, 6, 7, right? This is something that I'm borrowing. And then after that, the 8th bit into the second octet will be the host prefix. And then everything after that is going to be host. Correct? So based on this information, if we figure out the number of network, number of host, subnet mask, and ranges, then you can say that number of network is 2 to the power 7 there, which is, I would say, 128 again. And then number of network, what that would be? Number of network is going to be now 2 to the power 17. Do you understand that? And what's the value for 2 to the power 17? It's 131,072. And then if you figure out the subnet mask for that, it's 255.254.0.0, 8 bits and 7 bits slash 15. You get that? And then we come down to ranges. Now here's the thing. Of course, we are going to start at 10.0.0.0, but we also need to figure out the number of segments here as well. So if I divide this value by 256, which is 1,31,072 or 131,072, then the output that I get is 512. Correct me if I'm wrong. And you can see that the value over here is still not less than 256. So what do we do now? Because as we go according to the logic, you need to divide the value by 256 until you get it down less than 256. So how do you do that? You do that by further dividing that particular value again by 256, and then the output will be 2. Make sense? No, no, you don't need to divide it by 512. You need to divide it twice by 252, 2 to 256, and then the output is 2 over here. Now here's the thing. When we were not dividing anything, the changes that we used to do was into the last octet, that is class C, right? When we used to divide it for once in class B, the modification used to happen in third octet. And now that we are doing the changes for twice, the modification now shift over here to the second octet, where we can actually play there. Make sense? So how is it going to work? The thing is going to start at 10.0.0.0, and it is going to end at 10.1.255.255. And this entire network contains 131,072 IP addresses in it. Make sense? Because this entire three last octets are dedicated for host IDs. Cool. I hope you understand that. So just like that, what we are going to do, we'll write down the next block, and that next network is going to be 10.2.0.0, and it will end up at 10.3.255.255. And then you will have 10.4.0.0, which will end up at 10.5.255.255, and then 10.6.0.0 to 10.7.255.255. Like that, the last network will be 10.254.0.0 to 10. All 255. Make sense? And this entire thing will be 128 networks. Each network will have 131,072 IPs. Do you understand that? Perfect. So I request you to please try your hands on slash 14 slash 12 slash 11 and slash 10. See if these four things works for you, considering the same IP address there, 10.0.0.0. Okay, you can write down the first four and one last network there, not the everything, but see if it works for you. Okay, take some time, around 20 minutes, and then I'll see you back there. All right, I believe most of you are done with the example, and we can move on with the next thing. I'll however show you that how the calculation actually needs to be done. So let's say for 14, when we talk about that, if you do the scenario for slash instead of 15, let's say we are going to do it for slash 14. So in that case, you would see the number of network is going to be 2 to the power 6, right? And the number of host will be 2 to the power 18. It will increase there. Makes sense? And that's gonna give you a value which would of course be 262,144. And when you divide it by 256, you're gonna get a value that is 1024. That's why you again need to divide it, and then you get 4 as the answer, and that's the number of segment that you will merge. So the host will be somewhat around. Okay, I made kind of a mistake there, where 2 to the power 18 actually needs to be number of host. So I'll put it over here. There you go. And then number of network is 64. Yeah, I'll put that on charge, don't worry. Then the subnet mask, when we look at that, you say 255.255 dot 2 sorry 252.0.0, and then after that the ranges will be something like 10.0.0.0, and then you will end up at 10.3.255.255. The next network will be 10.4.0.0 to 10.7.255.255. And just like that, 10.8.0.0 to 10.11.255.255. Like that, you will reach out to 10.252.0.0 to 10.255.55. Like that, you will have such 64 networks. And each network will have 262,144 IP address per network. Make sense? Do you guys understand this? Perfect. So I believe most of you can practice the same over here. And then now we'll move on to the next thing. So see, whenever this was about subnetting, okay? Now we are going to move on with the next thing where we will now start discussing more about networks and how you can actually configure them. But before that, you need to understand that how these characteristics actually work there. Yeah, you need more practicing there. Now I told you that there are different type of networks that are present, right? Let me just put my thing on charge. So when we discuss about some of the things, that what are type of communications, or yeah, what are medium of communication that we have seen so far. So we discussed that there can be unicast, there can be multicast, and there can be something called broadcast. But this unicast, multicast, and broadcast actually works when you discuss about when the communication happens. So we are on a verge in order to understand what are the different type of devices that you have and some of the common terminologies that are associated with those terms. Make sense? Now pay your attention here. Usually, when I say that I want to connect two different networks together, or two different, I want to make a common network. So what do? You basically take a couple of computers and you connect them by using Ethernet cable, I can say. And usually this Ethernet cable will be something called Cat5 Express, okay, or it can be Cat6. These are two type of models of the cables that you actually use. And when you connect these, I would say, cables together, then it actually depends on the network interface card that is installed over here as well onto each and every computer. So you will have a network interface card, and that network interface card will have a connector called RJ45. Okay, every network interface card has something called RJ45, and you can Google what's RJ45. You will get to know about it. It's basically the port in which actually we plug our, I would say, Ethernet cable into, right? And we use that cable in order to do all sorts of communication, the basic communications that we do. Cool. Now, what would you do when I say that my requirement is not there to just connect two of these pieces together? My requirement is to connect multiple pieces together there. You get that? And how do we do that? We basically use some of the centralized device. And how do we do that? Let's say you have four PCs. You have this PC, then you have some other PC over here, and some other PC over here, and some other PC over here as well. If you want to communicate or if you want to connect all of these pieces there, then you need to use help of centralized device. And this centralized device in the early age of internet was something called hub. And what would you do when you connect these devices with the centralized device called hub? Then let's say that you want to send your traffic from PC number A to PC number D. So I'll name these PCs as well as A, B, C, and D. And when you do this type of communication, let's say these PCs also have some of the addressing that are configured on them. So PCA has an IP address 192.168.1.1. PCB has an IP address 192.168.1.2. PCC has an IP address called 192.168.1.3, and PCD has an IP address called 192.168.1.4. And it also has a MAC address as 1111.2222.3333 and 4444. You get that? These are the addressing parameters. Now, when I say that the communication actually needs to be done from here to here, then your PC actually will collect some of the information. What that would be? It will collect the information about source IP. The source IP is going to be 1.1. Then it's going to collect the information about destination IP. It's going to be 1.4. It's going to say what is the source MAC address. That's going to be 1111. And what would be the destination MAC address? That's going to be 4444. You understand that? And when you have such type of configuration there, then what's going to happen is once your PC actually sends some traffic to this destination, then who's going to receive it? It will be received by the hub there. And how will hub act on it? Anyone can tell us that into the chat? How will hub react to it? Hub will do broadcasting. That's actually correct. And that is exactly why we call hub as the dump device. Why so? Because when hub kind of receives such kind of communication, which is coming from this PC, and it needs to go out on this PC, But instead of forwarding that particular thing, I would say, to the hub, what hub does? Hub forwards that particular traffic on this, and on this. Makes sense? Except the port that the traffic was coming from, hub will forward the traffic to each and every port that is available there. Why so? Because hub doesn't have any sort of brains to process that particular frame or packet that is coming to it. You understand that? And for such reasons, we call hub as a dumb device. So when we review hub is called as a dumb device, and it cannot do unicasting or multicasting. It only does broadcasting. Make sense? It doesn't maintain any table, no information regarding the traffic. And then the most important characteristics, it works on half duplex. Okay, and shares collision domain. You get that? What these things means? It means that hub only has a single collision domain for each of its ports, for the entire ports, or the range of ports that it maintains. For example, let's say that A initiated a traffic that needs to be sent out to D, and at the same time C also initiated a traffic that needs to be given to the B. What happens then? This will actually cause something called collision. Make sense? And then hub will kind of initiate a jam signal to each and every port there, and then no transfer will be allowed for the random amount of time. So hub will send a jam signal with some random timer, and until that particular timer expires, nobody will be able to send or initiate any transport back then. You get that? Why so? Because hub doesn't understand how full duplex traffic actually works, which means that hub only knows how to send and receive traffic one at a time. Meaning it can either send a traffic on one port, or it can either receive the traffic on that particular port. And that's why we say that hub works on half duplex and it doesn't work on full duplex. So as there were multiple limitations that were actually available, then in the picture there comes switch, which acts as the successor of hub. So if we replace this picture, or if we replace this centralized device with something called switch, and switch has then all these different four ports that are connected, then would switch be able to communicate with all the other connected devices by using other type of mediums, be it unicasting, multicasting, or broadcasting? And would it be able to share some data according to the requirement? Of course, yes, right? Exactly. And that is where we use hub for the layer 2 device. And why do we call it as a layer 2 device? Because it works with the help of something called MAC addressing. Make sense? So if we talk about switch, then switch has certain characteristics as well. And where the first characteristic of switch specifies that it works on full duplex. Okay, then it has multiple collision domain. Okay, it supports, I would say, unicast, multicast, and broadcast. Exactly. If you want to understand what is collision domain, let's say, I'll give you an example. Let's say that you have something like this. For example, you have a classroom environment. And in that classroom environment, you see that there are around 10 people that are sitting in this classroom. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these 10 people have just one entry and exit door. That's basically the door that you have. Now, if I give an instruction to all of these that are sitting into the class, if I say that, hey everyone, please get up and get out of the class, then everyone will kind of gather over here. They will start walking off to the exit door, if I'm not wrong, right? And so does this device, this device, this device, this device, and this device will do. So what is going to happen over here? Over here, something will be caused as called as collision. And that's exactly the same, I would say, concept there. But instead of doing such type of collision, what would happen if I just like reverse everything and I say that instead of having the main door, everybody now will have their own entry and exit point like this. So one will go with this way, two will go this way, three will go this way, four will go this way, five will go this, six, seven, eight, 9, and 10. Will there be any chances of any collision there? There cannot be any collision in this type of scenario. Do you agree that? Exactly. Yeah, Amal, that's correct. It's just like a phone call that you can listen and speak at the same time on the phone call because it works on the model of full duplex. Make sense? So that's how switch is different, and switch has various other characteristics as well. So we call a switch a layer 2 device. Now if I give you a scenario for the same, because that might come up in your exam, let's say that you have this particular switch here, and this switch has different users. You have user A, you have user B, you have user C. How many collision domains will I have? Three collision domains, right? Now let's say that I basically connect another switch with this switch 2, and then I have this scenario like this, and that is D, E, F, and G. Now how many collision domains do I have? Exactly. You have 8 collision domains, which means this one, 2, 3, 4, 5, 6, 7, and 8. This common link between the switches will also be one of the collision domain there. So that's why totally you have 8 collision domains. Now let's say that with switch 1, there is a user or there is another device which is called as hub. And this hub also has different 4 users connected with it. Now how many collision domains do you actually have there? Perfect. You have 9 collision domains. Someone is saying 13. That is wrong. Why so? Because hub completely shares its entire collision domain will just be one collision domain. And that's how the scenario is going to be there. You get that? And that's how collision domains can be understood. Now, what is broadcast domain? Broadcast domain is something which is also referred to as layer 3 boundary. Okay, so when you have or when you get a router inside a network and then you connect multiple, I would say, switches with it. So if you have switch 1 there and switch 2 there, and both of these switches are somehow connected to the router. So how many collision domains do we have now in this scenario? Can I say 1, 2, 3, 4, 5, 6, 7, and 8? You have 8 collision domains there, and you just have one broadcast domain. Makes sense? You have 8 collision domains and you have one broadcast domain there. Now, if I say that I do not connect this particular switch over here, and instead of that, I make a connection of this switch directly with the router. Now, how many collision domains do you have? And how many broadcast domains do you have? Exactly. You have 8 collision domains and you have 2 broadcast domains. So when we figure that out, we come to a conclusion that if we talk about switch, then switch has one collision domain per port. And if we talk about broadcast domain, then switch have one broadcast domain per switch. Okay, per device I'm talking about. And if we talk about router, then one collision domain and one broadcast domain per port. That's what the difference is between the router and between the switch. You understand that? So this is how collision domains and this is how broadcast domains actually work. Now what we are going to do, we are just going to build up, I would say, a common topology, and we are going to configure a common topology and see how the communication can actually be done here. So the thing that we are going to use is Cisco Packet Tracer. We are going to use this Cisco Packet Tracer in order to do all our labs that we will be doing in this training. Okay, so give me just 2 minutes and I will share the software with you. If you don't have this, you can, some of you might have downloaded it from the internet as well. But I will put that particular thing for you guys on my drive link, and I will share the drive link with you in just 2 minutes. And then I'll tell you how you can install it, and then we will see how you can, I would say, use it. Any version after 5.3 will work for us. There is no limitation of what version do you actually want to install. I'll put the latest one there. Thank you. Yeah, guys, I'm putting the link. I actually had to connect with my hard drive and then upload it on the drive. Just 1 minute. All right, so in the chat section, you can find now Cisco Packet Tracer. For Windows machines, I have put that particular link there. And you guys can please click on the file and you can download that. Okay, you can download the file that I pasted into the chat and it should help you over there. No, we won't be using GNS3. Yeah, this is for Windows 64 bits. Packet tracer is used for all the CCNA studies. Usually, we use GNS3 when we like would jump into CCNP studies also. Yeah, you can use that on server version as well. Not an issue there. And if any one of you is using Mac as the computer, Apple MacBook, so I'm also putting the link for that. You can download that particular Mac version of Packet Tracer as well if you need it. All right, guys. So you guys can download it and install it by yourself. Okay, it's pretty easy procedure. There is no special instructions that needs to be followed while installing it. However, as I already have that software installed in my PC, so I'm going to share my screen with you, and we will see how a normal network can be created. Tarun, please turn off your camera. The user logins can be logged in by using either Cisco account or you can skip the login. So when you open up the software, like for example, I have my Cisco Packet Tracer installed. This is the one, Cisco Packet Tracer. So when I open that up, cool. This is Cisco Packet Tracer that we are going to use, and I hope everybody will be familiar with that soon. There is no credential that needs to be used. When you are being prompted for the credentials, you can see at the lower right side bottom corner, there is a button for guest login. So you can click on that guest login, and there you will need to probably wait for 15 seconds, and after that you will be able to continue that. Okay, while it gets downloaded for some of you, while you are in the process of installation or so, what we will do, I will try to introduce you guys with the overview of how the software actually works and the architecture of it. So you can see that there are different options that are available. I have shared my computer screen and I believe almost everyone can see that. If you're not able to see the screen, you can drop the session and join back again. And so these are the different options. Okay, you can see that this is basically I would say the main toolbar, the main menu option where you have file option. You can click create a new file here. You can open up a new file. You can save your project. You can print your topology. You can get some information and so on. So this is copy, paste, undo, redo, zoom in, zoom out, zoom reset, and some of the coloring options also. Okay, we won't be playing with much of it. Then after that, you can see this is the toolbar that we use. So this toolbar is for selecting the device. This is for zooming in the topology or inspecting something. This is to delete some of the objects of the topology. Then you have, I would say, to select a specific thing from the topology. Then you have around like if you want to make any notes, you can select this option. If you want to draw some of the designs there, then be it rectangle, square, or so, in order to organize the topology, you can use these. And these two tools are basically used in order to simulate a traffic flow. So this is kind of an ICMP traffic. You can select these messages and you can use them in order to send from one device to other device. Make sense? Then, if you see this empty area over here, this is actually where we build up our topology. Okay, this empty area is where we will be creating our topology there. And then at the bottom corner, these are different sets of devices. So you have two different columns. One is this row, which actually gives you different view of different devices. So the first row indicates different category of devices, and every category will have different types of devices, and every type will have different models in it. So category, models, category, types, and models. These are the three options that you have here. If we look at the first row, the first category is network devices. And then the type of devices that we have are routers, switches, for hubs, wireless devices, security devices, WAN emulation devices, and so on. If I click on the routers, then on the next column, I will see different type of router that are available with us. Make sense? If I see a click on switch there, then these will be the different type of switches that you have here. If I check the hubs, these are the hubs that you have. If I check at the, I would say, wireless devices, these are different wireless devices that you have. Make sense? Just like that, these are the different categories of these. Yeah, the devices that you will see will only be of Cisco, as it's a Cisco packet tracer, and there won't be any devices from any other vendor. Then, if you click on some other type of device, let's say end devices, when you click on that, then you see the end device section over here. Then you have home devices, smart city devices, industrial devices, and power grid devices. So in the end device section itself, you will be able to see there's a PC, there's a laptop, a server, a Meraki server, printer, IP phone, VoIP device, normal phone, television, wireless tablet, so on, so on, so. Okay. And then you can see that on the home over here, you will find your IoT AC, your appliance, your battery, or your Bluetooth speaker, or your carbon dioxide detector, or so on. So, but the only devices that we'll be working with usually be routers, switches, and I would say PCs also. So in order to build up a topology, what you need to do, you need to click on the first section, which is network devices. Then you go to the, I would say, router section. And from the router section, remember this thing, you will always be using a device that is called as PT router. Okay, we will be using a device that is called as PT router. Makes sense? We won't be using any other router because PT router gives us enough numbers of, I would say, interfaces that we'll be requiring. So we are going to use PT router because it has all the default settings of the number of interfaces that we need. Other devices will be needed to modify, and some of the commands will not be supporting over there or so. So this is a standard router that we use for all type of configuration. Now, once you see the device that you need to use, then you can click on it and drag it up like this onto the workspace, and you can leave it like that. And then your router will be pasted over there into the topology or into the workspace. Then I'll do that again. When you want to delete it, you can actually select it, or you can actually select it like this, and then you can click on delete. So when you click on delete here, there you go, it's done. And then you come back to the selection method like this. When you are over here, you select a device and you drag it up into the working topology, and then that's how you like get a device there. The next option or the next device that we are going to work with is going to be a layer 2 device, which is a switch. So from the network devices section, we'll select, I would say, a switch now. And when I click on switch, then these are different switches that we have. We will always be working, here's the thing, we will always be working with a switch that is 2960 here. Make sense? So I'm going to put that particular file over there, which is a 2960 series switch. And then I would say after that, what we are going to do after putting a switch there, which is 2960, which is the first switch in the category, then you can actually select the end devices section. And in that end devices section, you select the PC from here or the laptop, whatever you choose. So you can click and put up multiple PCs. I'll put a PC there and I'll put a laptop there. These are the two devices that we will have. You get that? And then after that, yeah, these devices are still used. Okay. And then after that, you can say that you click on the device, or you click on something that is called as connections. And then you can see that if I click on the connections button, then there will be multiple type of cables that you can see here. Okay, there is a cable called automatic, there is a cable called console cable, copper straight through cable, copper crossover cable, and so on, so on, so fiber, and every other thing. The cable that we will be using in order to connect any device is automatically choose connection type, the first one. So we click on this particular automatically choose connection type. And then once you select the cable, you can see my cursor has changed to something else. And then after that, you basically click on over here on the router, there you drag it up, and then you connect it with the switch there, like that. Then just like that, you click over here, again select the cable, click on the device, drag it up, and click on the destination device. Make sense? And just like that, you select the cable again, click on the device, drag, and again click that. Do you understand how the cable connection is done? However, there are different cables as well. Okay, and most of you might be confused between why are we using automatic and not the straight through, and so we'll be discussing about different cables that we have later in the coming sections, but as of now just use this automatically choose connection cable. So that's how we work with it. Make sense? And the network that we're going to configure for ourselves is something called as, so you can create a note over here. I'll select a note and then I'll put it over here in a way that 192.168. 1.0/24. This is going to be the network that we are going to configure for ourselves. Do you understand it? You're pretty good. So take some time, install the software that I have provided you, and see if you're able to come up with the topology that I have created. Guys, you need to I would say cooperate with this thing, that my screen is continuously shared, okay, and there is no issue with my me sharing the screen or me speaking something. Whenever you listen something, I'm talking. Whenever you're not listening something, it means that I might be on mute, or I might have given some example there. Okay, I'm connected to an internet of 500 mbps, so I will not have probably any issue at my end when I'm sharing my screen, or when I'm, like I would say, speaking something. I'm on a strong internet connection, and there won't be any issue with you. So if you guys are not able to see any screen, if you guys are not listening something, that might be the issue at your internet connection, or might be some network issue also. I would suggest you to drop the session and rejoin it again. Okay, if you guys are experiencing, if you would put so much of messages, not listening, not hearing, display not, then I miss out the important chats into the chat section. And as we have so many people joining, it gets hard for me to cater everyone as well. So please cooperate for that, so that I can like deliver the session in a, you can say, much better way possible. Yeah, thank you so much for understanding, and please cooperate in that way. The cable name that we are actually using is automatically choose connection type. I'll again try to create this image. I've selected the entire image. I'll delete it. And then after deleting it, what I'll do, I'll go into the router section, which is the network devices. When I go to network device section, I select the routers, which is the first device. And then after that, these are the different devices or routers that we have. So what we select PT router. And then I drag this particular PT router here, and then after that we select another device. So after selecting the router, then I go to the switch section, which is the second one, and then after that I select a device which is 2960, and I drag it there. And just like that, I will go into the end device section, which is the second one. So I click on this end device section, and then I select this end devices and drag a PC there, and drag a laptop there. And once you have your devices ready, then I can actually go to the cable type, select the cable, and then I can automatically choose connection type, and say router with switch. And then after that, switch with PC, and switch with laptop. That's how we do the connections there. So take some time, okay? Take around 5 or 10 minutes of time. And those who have not downloaded the thing, please let them download. Please let them come up with the topology, and then we'll move on with the next thing. Till then, you can consider a break time. Okay? Thank you. I'll be back within like 10 minutes or so. Yeah, hey there. So I hope most of you are done installing the thing. Now we'll kind of see how the communication actually works between two of the devices. And when we look at it, then what we need to do is first we will only be configuring the thing that is like PCs. So as of now, there is no communication between the devices that you have. And what we will be doing is we'll be working with, I would say, a switch there. And let's say I have a switch here. And then inside of that switch, you have different PCs. So I'll take around 4 PCs here. And when I say that I have a switch in between, then I can connect these switches with the PCs. And then after that, just a minute. Yeah, guys, so here you can connect your switches or your PCs with the switch that you have. And you can see once I connect these cable, then at that time the interface is red. It means that the interface is coming up to green. Okay, so it takes some time for a switch to turn on a specific interface there. And if I go and configure like some IP addresses there, now we are using a network that is 192.168.1.0/24, in which the range of IP address would be 192.168.1.0 to 192.168.1.255. But as you know, 1.0 will be your network ID, okay, and 1.255 will be your broadcast ID. Makes sense? So the available or the usable IP range is something called 192.168.1.1 to 192.168.1.254. Out of that, we'll assign 1.1 to the first PC, 1.2 here, 1.3 and 1.4 like that. So in order to assign IP addresses to something, let's say, in order to assign IP address to the PCs, you can click on this PC and then you can select the desktop section from this particular window. And then after that, you can click on IP configuration. I'll again do that. Click on the PC, then click on desktop, and then click on IP configuration. And then you go into static and then configure 192.168.1.1. And then when you press tab, then it will automatically configure the subnet mask here. Make sense? Then that's the only thing that you need to configure as of now. Then you close this window, go to the second PC, then configure desktop, and then IP configuration. And then over here you say 192.168.1.2, and then give a tab there, and then close it down. And then go to the third PC, go desktop, IP configuration, and say 192.168.1.3 there, and then tab. Or I believe I have configured, yeah. And then go to the fourth one, go to desktop, IP configuration, and say 192.168.1.4 and tab, and you close it down. Like that, you basically do the configuration of these computers. And then once your configuration is done, then in order to check whether the communication is happening or not, what you can do, you can actually select this particular message here that you can see. Okay, you select this message, and from here, when you select it, you can see a message has been selected. And then you click on the source PC, and then you go and click on the destination PC, and then you click here. So once you do this communication, on the right side, lower bottom corner, you can see that the communication between PC2 and PC5 has been successful. This is my PC2, this is my PC5. Okay, so the communication between that is successful. Yeah, there. So I'll do that again there. That so what do you need to do after you design the IP, you design the network there, then you click on the PC, and then you go to the desktop section and go to the IP configuration. And then after that, you configure IP address, type down IP and subnet mask here. So when you type down IP and click on subnet mask section, it will automatically detect that. There's no issue to detect that thing. Get that? And then you close it up. Then you click on the other PC, IP config and configure it. So we are providing 1.1 here. Then we are providing 1.2 here. Then we are providing 1.3 here and 1.4 here. That's how we are basically provisioning the IP configurations. Makes sense? Do you understand that? And then when you're done configuring the IPs, then you can select a message from here, which is this. Select it, then click on the source button and click on the destination. And that's how you basically check from PC2 to PC4 the communication was successful. So this is exactly how you check whether the communication between your PCs are working or not. Do you understand it? Go ahead, try this thing and see if it works for you. There is no IP address that has been given to the switch. Switch doesn't work with any of the IPs. Switch is a layer 2 device and it doesn't configure or it doesn't work with any of the IP. It is just connecting you guys together or it is just connecting the PCs together. How to check the connection is successful can be checked by sending the message. Select a message from here and click on the PC, click on this destination, and over here. This is how it shows that it is successful. What is 802.11? It won't ask you for any of this. if you don't see the message box on the right side, it might be shrink down like this. So if your window is like this, you will see an arrow over here, right at my cursor, where that is. So you can click on this arrow and the tray will come up where you can actually check your scenario. So I hope you understand that. This is where you see the message. If you want to send a message, you click over here. Your subnet mask will automatically come up if you are working, if you are configuring it. That's how you check if your message is successful or not. Okay, Nelson will be talking about how broadcasting and other things are done in the coming classes. So don't worry about that. Patty, you are stuck over there because you can see, yeah, you're getting that type of screen because you have selected simulation in your window. So if you see my cursor, you need to be in real time and not in simulation. Yep, just fix that thing. When you're done, and if your window is full, you can just directly click on this delete option, and your window of your messages can go like that. You cannot see your message, Nikki, because you haven't sent any message yet. You need to send a message after you configure the IP address. Then what you do, you click on the message, you send from one device to the other device like this, and then you will see successful. Okay, who all are done doing this particular lab? Yusuf, as I told you, that your tray for checking out the lab is actually hidden. So what you need to do is you need to go into this particular, you need to click on this window. If you can see my cursor, once you click on this arrow, then your tray for the checking the message will come up there. Perfect. All right. I hope you understand the concept of how you kind of access the things and so. So what you can do now is you can play around with this software a bit, and I would say that was basically all that we had to discuss in this class. We are going pretty with a good pace there. Where the next section is we will be starting discussing about the operating system of Cisco and how it works. Then we will discuss about different ports that we have when we will work with router. I'll tell you about Ethernet, fast Ethernet, gigabit Ethernet, then different cables straight through crossover fiber and how they actually work. Okay, we'll talk about then with routing, how you can implement routing, static routing, dynamic routing, and so on. So all those concepts are coming up in line for you. So don't worry about the amount of topics that are going to be covered. I'll tell you enough of the topics that I can cover. Okay. The lab assignment can be the same. I'll request you to play around, design different topologies for you guys. Okay, and see how it works for you. The firewalls, load balancer, IPS, IDS is none of our business in this course. Okay, we're talking about very fundamental knowledge, but they are there available into the packet tracer. So if you know how to work with them, you can get that there. Okay. Yeah. So the purpose for this particular class is always good. And thank you for all your patience over there while I solve the doubts and so. Yeah, and I hope you enjoyed the session today. Thank you so much for tuning in, and I'll guys see you in next Saturday on the same time. Till then, thank you so much. Take care of yourself and be safe wherever you are. I'll see you guys next week, next Saturday, with another exciting session. You'll get the recording link soon in the Telegram group. So keep touched over there, and I'll see you guys in the next week. Thank you so much. Take care of yourself. Bye bye. And also, please do follow us on LinkedIn, to our company page as well, and to my account as well, so that we can share our upcoming assignments and share our upcoming free courses, or even the other courses with the others as well, or with the needy ones. So thank you so much. Yeah, I'll put my LinkedIn ID directly into the chat. Even if you like, even if you go on Google and type down Abhijit Bakale LinkedIn, then you will find my LinkedIn there. And this is basically my LinkedIn handle. So I'll copy this and I'll paste it into the chat for you guys. Please follow us on LinkedIn so that you guys will be updated over there. Thank you so much. Take care of yourself. Bye bye. And also follow PyNet Labs. That's our company page there. Cool. Thanks everyone. Thank you. Bye bye.